have some experience with limits, we can tackle this very significant limit from calculus, the difference quotient. Before we look at this difference quotient, let's just review that if you have a function and you're asked to evaluate something like f of 5, you're simply asked to plug this 5 in for x. F of 5 is 2 times 5 plus 3, which of course equals 13. If you were asked to evaluate something like f of x plus 1, you're going to plug x plus 1 in for x. F of x plus 1 is 2 times x plus 1 plus 3, which I suppose you could simplify to equal 2x plus 5. So, of course, if we're going to evaluate f of x plus h, we're going to plug x plus h in for x. Now, I don't know how much simplifying I can do here. I can distribute this 2, of course, and that would be equivalent to 2x plus 2h plus 3, but there aren't really any more like terms we can put together. So let's see if we can evaluate this limit of what is known as the difference quotient. It's called the difference quotient because the numerator is a difference, and we're dividing, so we're going to get a quotient. We already know that f of x plus h is 2x plus 2h plus 3. I then need to subtract f of x. I'll subtract what f of x is. F of x is 2x plus 3. Let me put that in parentheses. And I'm going to divide by h. I'm going to distribute this negative and get rid of these parentheses. And notice in the numerator, this positive 2x will cancel out with this negative 2x, and this positive 3 will cancel out with this negative 3, and I'm left with 2h over h. Of course, if I plugged in 0, 2 times 0 is 0, and 0 in the denominator, 0 divided by 0 is undefined. But I can cross these h's off. And now I don't need to worry about plugging in 0, because there's nowhere left to plug it. This equals 2. I think we better look at another one of those. Here's another function, and to evaluate something like f of 2, you just plug 2 in for x. We can, of course, simplify that. 4 minus 6 is negative 2 plus 4. This apparently equals positive 2. We can express f of x plus 1 by plugging x plus 1 in for x. If I expand x plus 1 squared, it's x squared plus 2x plus 1, and I can distribute this negative 3, and I could then gather my like terms. I have an x squared, I have a negative x, and positive 1 and negative 3 is negative 2 plus 4 is positive 2. If we were asked to evaluate f of x plus h, we would plug x plus h in for x. If I squared x plus h, I would get x squared plus 2xh plus h squared. When I distribute this negative, I get negative 3x and negative 3h. And then, of course, there's that positive 4. All right, unfortunately, we can't go any further because I don't really see any like terms over there. All right, let's see what happens when we evaluate this difference quotient. It's the limit as h approaches 0 of f of x plus h, which we have right over here. And we're then going to subtract f of x. We're going to subtract the original function. And we're going to divide it by h. Let me distribute this negative to the original f of x. And now there should be a bunch of terms in the numerator that cancel out. This positive x squared will cancel out with this negative x squared, and this negative 3x will cancel out with this positive 3x, not to mention this positive 4 will cancel out with this negative 4. I'm left with the limit as h approaches 0 of 2xh plus h squared minus 3h all over h. Now fortunately, all the terms in the numerator have an h. I'm going to factor that h out. Notice my numerator is still 2xh plus h squared, h times h is h squared, minus 3h. So I haven't really changed anything. But now I can divide these h's out. And I'm left with the limit as h approaches 0 of simply 2x plus h minus 3. Now I can safely plug in 0 and not worry about getting 0 in the denominator. If I plug 0 in for h, I'm left with my result, which is just 2x minus 3. This result of 2x minus 3 has much significance in calculus, and we'll be taking a look at that in our next lesson. Let's look at one last example. Of course, to evaluate f of 11, I'm going to simply plug 11 in for x. This is the square root of 11 minus 2, which is, of course, the square root of 9, which equals 3. To evaluate f of x plus 1, I'm going to plug x plus 1 in for x. I can combine my like terms of positive 1 and negative 2. This is the square root of x minus 1. To evaluate f of x plus h, we're going to simply plug x plus h in for x. There's nothing more we can do with this. There are no like terms to combine. So let's take a look at our difference quotient. It's the limit as h approaches 0 of f of x plus h minus f of x. Well, f of x plus h is right here, minus our original function, so minus f of x, and then all over h. Well, notice if I plug 0 in for h right now, if I put a 0 here, inside this radical would be x plus 0 minus 2, or it would just be radical x minus 2. Radical x minus 2 minus radical x minus 2 would be 0. This would be 0 over 0. And that always happens with the difference quotient. If you plug 0 in for h, you get f of x minus f of x, you get 0 over 0. So we need to do something to this to get something to divide out in the numerator and the denominator. I'm going to try multiplying by the conjugate of the numerator. So I'm still going to have the limit as h approaches 0, and my denominator is h times this binomial. I'm not going to distribute the h. I'm simply going to indicate h times that binomial. Now, my numerator, I have a binomial times a binomial. But they're conjugate pairs, so I know lots of things are going to cancel out. First of all, the square root of x plus h minus 2 times the square root of x plus h minus 2 is just x plus h minus 2. I know this outside and this inside are going to cancel because they're conjugates. Then I just need to multiply negative radical x minus 2 times positive radical x minus 2. Well, of course, a negative times a positive is negative, and radical x minus 2 times radical x minus 2 is x minus 2, but I'm going to put that in parentheses. Let me distribute this negative to both of these terms. And now watch what cancels out on the top. My positive x cancels out with my negative x, my negative 2 cancels out with my positive 2, and I'm left with just that h. My denominator is something times something. My numerator is just h, or you can think of it as 1 times h if that helps. And now hopefully you see that we can cancel these h's out. And I can now safely plug the 0 in for h. If I put a 0 in for h in my denominator, I'll have radical x minus 2 plus radical x minus 2. Well, radical x minus 2 plus radical x minus 2 is 2 radical x minus 2. My result is 1 over 2 radical x minus 2, and in our next lesson, we'll see the significance of this. All right, time to go get those trithes done.